All right, well, welcome back, everyone. Let's go ahead and get started with making decisions and the if and switch statements. These are really important tools that you'll use very often in C++ programming. All right, so in today's video, we'll go ahead and cover a few things here. First, we'll briefly review some of the topics from last time about data types and static cast. Then, we'll learn about Boolean statements and how we use Boolean statements to check whether a condition is true or false. Then we'll learn how to use Boolean statements in order to make decisions. And we will see how we can use if, else, elseif, and switch statements to help us create branching programs with multiple possible paths. And finally, we'll start talking a bit about debugging programs and things to watch out for when making decisions in C++. So let's start with a little bit of review from last time. You'll recall that we covered static cast when we reviewed data types. And you'll remember static cast can be used to read variables of one data type as another data type. So if you'd like, take a moment and pause this video and see if you can correctly identify what the outputs will be. So let's start with the first line here, first cout statement. Cout my number. Well, my number was initialized to 1 divided by 2. But here, the 1 and the 2 are both ints. So if we have 1 divided by 2 and we have an int divided by an int, we get 0.5, but this will be converted to an int because our initial values were ints. If we convert 0.5 to an int, we end up with 0 as our output. So even though we had a double that we were trying to store that my number in, because we divided two ints over here, that 1 divided by 2 became a 0 before we could store it in the double. Let's now take a look at our next line. So in the second group of statements, we say my number is equal to static cast double of 1 divided by 2. So here, static cast double of 1 will read 1 as a double. Notice I'm using the word read here. So it's important to note that the data type is not changed. We're just temporarily reading that value as another type. So in this case, if we take static cast double of 1, we read that one as a double and we divide by 2. So we have 1 that's read as a double, divided by 2, which is an int. Well, a double divided by int is going to be equal to 0.5. That's stored as a double. So notice we keep our decimals because we used static cast double and we read the 1 as a double type. Remember, if we divide a double by an int, the result will be a double because that is the more precise data type. So the output of line 2 is going to be 0.5. How about line 3? Well, we need to be careful in line 3 because notice what happened here. Both the 1 and the 2 are inside the parentheses. So here we are reading 1 divided by 2 as a double. But we must perform the division first. So 1 divided by 2 will actually be dividing 2 ints, right? We'll divide 1 and 2. So that's actually going to be equal to 0. Because remember, this result is also an int. By the same reasoning we explained earlier, if we divide 2 ints, our result will be an int. 0.5 will be truncated to 0. So static cast double with 1/2 in parentheses becomes static cast double of 0. So the output of line 3 is actually going to be 0. Let's look at our last line. Here we are taking 1 divided by static cast double 2. So this time we're dividing 1, which is an int, by the number 2, read as a double. Here, our result will be 0.5, read as a double, because double is the more precise type. So line 4, the output will be 0.5. Everybody see the subtle differences with each of these outputs? Main thing you want to be careful of is make sure you use static cast properly. Remember, you want to convert the type before performing any sort of math that would create truncation. In line 3, we should have just put one of the numbers in parentheses, not both. Because here, the truncation happens too early, and we lose the decimal place. So be careful, if you do want to read an int as a double type, make sure you perform the static cast before doing any math that might cause you to lose decimals. All right. So let's just briefly review a little bit more from our previous video. Previously, we learned how important it is to use the correct data types. And so we learned that if you try to store a decimal number in an int, we will lose the decimal places. So this is called a truncation error. For example, if I try to store 99.5 in an int, only the whole number will be stored, the 0.5 is lost. And remember, rounding does not happen. The decimal is just completely eliminated. Next one. We covered those rules about coercion, where if you do math with two different data types, the result depends on those data types. And generally, the result will be converted to the more precise data type, if the data types are different. For example, if we add an int variable plus a double variable, the result will be a double type, because a double type is the higher precision. But similarly, if we were to divide an int by an int, that will give us an int type result, because it will have the same precision as the inputs. So be careful. Make sure that you do not accidentally lose data when doing math with variables of different data types. And be especially careful when working with int variables, because if you produce a decimal value, you might lose data. It's a good idea to use static cast and double variables if you expect that decimals may be produced. Other points. Remember, more precision requires data types with more memory. So if you need to store more numbers, like a very large number, very small number, you need more memory for that precision. Very small, very large numbers require more memory because those numbers have more digits to store. Finally, remember that int variables are stored as exact values, while doubles have some error because you have your known decimal places, but there will be some random stuff due to memory limitations. So int variables are actually stored as exact whole number values, while doubles may contain this error once we pass the precision limit of the double. Once again, just to quickly recap static cast, remember how static cast works is you put the desired type in the triangular brackets. So we use this to temporarily read or display the variable as the type inside the triangle brackets. For example, if you wanted to find the slope and x and y might be integer values, you could use static cast double to read. In this case, it will read y2 minus y1 as a double value. This will help avoid losing decimal places. If we were to be dividing int values. So static cast is also useful to see the int value associated with the char type. For example, every character on the keyboard has an integer number associated with it. So if you use static cast, you can actually convert a char or a character to the corresponding int value. This is useful for encryption or decryption if you want to convert between characters and the Unicode numbers. And we'll take a closer look at this in the future assignments. All right, let's do one more review question here. So here we have a main function, and we're trying to output this value number. Just a nice cout statement there. Do you have any idea if anything is wrong with this code? Take a moment and think about it. Is there something wrong here? Let's ask a question. What is number's initial value? Now, how can we add 1 to number if we don't know what number is? So you might have been thinking number is uninitialized. So the thing that's wrong with this code is that we need to initialize number. We need to give it a starting value. Otherwise, our compiler may return an error. Our compiler may assume that number is 0 initially, or the compiler might just return some random data that happened to be in number's memory. So always remember to initialize your variables before doing math with them. All right, so let's go ahead and move on to our new topics about Boolean statements. And remember, if you have any questions on what we've covered so far, feel free to reach out. Okay, so far, all of the programs we have written have followed a nice linear path. So far, our programs have only produced one result. But what happens if we need to make a choice? What if our program's output needs to change depending on what input the user gave? C++ has many tools available to help us make choices. And so we actually have some formal definitions for these tools. So flow of control is a term which refers to the order in which our program statements are executed. And then a branch is basically a choice. So a branch allows a program to choose between alternatives. And so starting today, we're going to learn about some ways to make choices. So here we're going to talk about if and else statements and switch statements. And next time, we will talk about loops. And one of the best ways to get really comfortable with these different types of tools is to really practice using them. So I would encourage you as much as possible while you're watching this video, open open up your IDE or CLion, whatever IDE you happen to have available, open it up and code along with me. Play along with the examples. And you'll see that by coding and practicing yourself, you will learn the material a lot more easily. Okay, so in addition to making choices, or in addition to using flow of control and loops and if statements, we need to be able to check conditions. And so we use these things called Boolean expressions to check whether something is true or false. And so you might remember the bool type variable. Bool type variable stores a true or false. And so Boolean expressions are an expression that will give a bool result. So we'll see Boolean expressions must be either true or false. These are important because Boolean expressions are the things that help us make decisions. If something is true, we might choose one path. If something's false, we might do something else. So the Boolean expressions are the things that enable us to make decisions in our programs. Here's some examples of Boolean expressions. One of the simplest examples are the comparison operators. Remember greater than and less than from math class? We call these comparison operators in C++. And we use them to compare variables or numbers. Just like in math class, we have greater than or less than, and notice they would return true if the item here is greater than, if A is greater than B, whatever these are, they will return true if the expression is satisfied. They return true if the expression is true. Equality operator is interesting. This one compares values. So here, we return true if hours and 40 are the same. So if hours is the same as 40, if these are equal, then we return true. Otherwise, we return false. Notice this is a double equal sign. This is not to be confused with the single equal, which assigns value. We also have not equal to that works in a similar way. It returns true if the things are not equal to each other. And we also have greater than or equal to and less than or equal to. These work very similar to what you may have learned in math class. There's also some other Boolean operators that are very useful. Double ampersand is also called the AND operator. AND operator will be true only if both expressions are true. For example, if we have 2 is less than x and x is less than 7, this will be true only if x is less than 2 and if x is greater than 2 and x is less than 7. Also, we have the OR operator. So this vertical bar that's on the same key on your keyboard, it's on the same key as the vertical slash. So this keyboard key is usually above the Enter key. So that vertical bar is what we use for the OR symbol. And notice there's no spaces between the two vertical bars. So the OR operator is interesting because it's true if either or both expressions are true. So if I have this example here, if x double equals 1 or x double equals y, this will return true if x is 1, or we can say and or if x is y, or if x is 1 and y is 1, right? So basically, if either or both of the expressions are true, then the OR statement will return true. Another Boolean operator that is sometimes used is the NOT operator. This one is a little bit less common because it can make expressions difficult to understand. So you want to be careful to use it when appropriate. Sometimes it's easier to just use and or instead, and your expression might be clearer. So here, for example, you could say not x is less than y, and this will return true if x is not less than y. Sometimes this is confusing. It might be easier to just instead write x greater than or equal to y and have it return true if x is greater than or equal to y. So again, sometimes the not expression can be a little bit confusing. Another one, not x double equals y. That will be true if x is not equal to y. You could equivalently write x not equals to y like this. So it's also very important when we talk Boolean expressions to make sure you know the difference between single equal and double equal. Remember, single equal is called the assignment operator. And it assigns value. So we see, for example, if x is equal to 3, the equal sign assigns 3 to x. Make sure you do not confuse that with double equal. Double equal is an equality operator. It compares values. And notice that double equal will return true if the two values are the same. For example, x double equal 3 returns true if x is 3. This difference is very, very important. So make sure, as you start practicing writing Boolean expressions, make sure you use the correct operator. Single equal for assigning value, double equal for comparing value. very important to know the difference between these two. Okay, when we talk Boolean operators, it's also important to talk about precedence. When we say precedence, we're talking about order of operations, or which expression is evaluated first. So the general rule is that if an operator has equal precedence with another, we perform those operations from left to right. Kind of similar to math, right? But there's a couple special exceptions for C++. So C++ has these things called unary operators. So for example, if we have a variable like num++, remember that means num equals num plus 1. So if we have one of these unary operators like plus plus, notice those are performed from right to left. You also want to make sure you use parentheses to guarantee if you need a certain expression to be evaluated first. This table summarizes the precedence of different Boolean operators. So notice the unary operators are done first. Then we have multiply, divide, modulus, add, subtract, then comparison, and an OR. I don't expect you to memorize this table, but I do expect that you know how to write correct Boolean expressions. If I were to give you a programming assignment that required you to write Boolean expressions, you would need to make sure you followed these rules in order for that program to run correctly. So keep this table handy for your reference as you get comfortable writing Boolean expressions. And remember, if you want to guarantee that an expression will be evaluated first, you can put that expression inside parentheses. One other thing to watch out for. Remember in math class, we can do things like if x is less than y is less than z. This doesn't work in C++. In C++, we have to put each expression in pairs. We would need to equivalently write if x is less than y and y is less than z. So if you have an inequality with 3 or more items, you need to split inequalities so that we compare two values at a time. Let's go ahead and try a couple examples for practice. If you'd like, I'd encourage you to pause the video for each of these examples, try it on your own, and see if you get the right answer. Let's go ahead and start with this first one. Suppose I want to check whether exam score equals 0 and final score equals 0. So notice the and here. Notice in this case, I want to use and. So I can immediately eliminate these because this is the OR operator. We don't want OR. Next, notice what we're trying to do. we want to compare exam score and 0. And we want to compare final score and 0. So in order to compare, do we use single equal or double equal? Yeah, remember in this case, we need to use double equal to compare values. So here, this statement will return true if both exam score and final score are 0. Let's try another one. How would we write this statement in C++? We want to check whether x is greater than 3 and less than 5. Take a moment and think about it. All right, so you'll probably remember, in this case, we cannot do choice C. Remember, we need to compare values 2 at a time. We also want to use and, not or, so that leaves us with either choice B or choice D. So in this case, notice here, we can't say x is less than 3 and less than 5. We need to have an x there. The correct answer here is choice B. We want to check, is x greater than 3? And x less than 5. Choice B is the correct result. A couple other important details to note. First is and statements. It's very important to note that if any part of an and statement is evaluated to false, the entire statement will immediately become false. In fact, the computer will ignore the rest of the statement. There's a special name for this. It's called short circuit evaluation. So here you can see that if the second item in our Boolean statement was false, these other items are all ignored and not checked. So you want to be a little careful here, because what if you had some invalid tests in those other statements? Those would not even be checked. We would immediately stop with the false. Sometimes this is also helpful if you want to prevent yourself from dividing by 0 or something like that. You could immediately stop execution of this statement before you divided by 0 or did something that would create a runtime error. So just be aware that if any part of that and statement is false, the entire statement will immediately be evaluated to false. All right, so once again, if any part of that and statement evaluates to false, the entire statement will evaluate to false. It turns out that there's a similar rule with or statements. So remember, an or statement will return true as long as at least one part of that or statement is true. So if any part of an or statement evaluates true, the entire statement will immediately be read as true. The computer is not going to bother to read the rest of the statement. So the rest of the stuff in that statement could even be false, and computer wouldn't care. It wouldn't even read it. This is another example of what's called short circuit evaluation. So be mindful of this rule. Every once in a while, you might need to be careful of this when designing your Boolean statements. So there's one other very important thing to note about true versus false. So in a Boolean expression, 0 or false are always read as false. Anything else inside that Boolean statement will be read as true. We'll see some examples of this in just a moment. But if you want to guarantee that your Boolean expression will always evaluate to false, you need to make sure that the final result will evaluate to a false expression. Okay, so let's go ahead and see, how do we actually use these things? How do we use a Boolean expression in our programs? One of the most common ways that we use Boolean expressions in programs is by writing if statements. So an if statement will check whether the Boolean expression is true. If the Boolean expression is true, then the statement that follows is executed. If our Boolean expression is false, then that statement is completely skipped. For example, take a look at this flowchart. Are you hungry? This could be our Boolean expression. If hungry is true, if we are hungry, then we eat a meal. That's the statement in here. But if we are not hungry, the statement is skipped and our program proceeds to the next section. Another thing you might have noticed about this if statement is there is no semicolon right after the parentheses. Instead, the semicolon goes after the statement. Let's take a look at some more examples. How about this? Take a look at this program about body temperature. So here we've declared a double variable named temperature, and we ask the user, what's your temperature? Then we have an if statement. If temperature is greater than 98.6 Fahrenheit, then, oh no, you have a fever. Take a moment and think about it. What will this program do? All right, so we can at least probably see what the intent of this program was. We wanted to check the person's body temperature, and if the temperature was greater than some value, then we output our message. Should have done B, right? If you enter a temperature above 98.6, it will output, oh no, you have a fever. But is that actually what this program does? And notice the semicolon here. I thought we said that we didn't want to have semicolons right after our if statement. Let's take a look in Sea Lion and try running this program. Okay, so now we've opened up Sea Lion, and we have our program here. So we're being asked, what is our body temperature? And notice we take in temperature, but wait a minute, Sea Lion's giving us a warning. If statement has an empty body. Okay, well, let's just go ahead and run this anyway and see what happens. So I'll go ahead and select my temperature program and push run. So what's my body temperature? Well, maybe I'm a little cold. Maybe I'm 97. Uh-oh. If I'm 97 Fahrenheit, I shouldn't have a fever yet because I'm less than 98.6. That's strange. Let's try another number. What if I do have a fever? What if my body temperature is 100 Fahrenheit? Well, that's correct. But why am I getting, oh no, you have a fever, even if my temperature is less than 98.6? It seems like this if statement is not working at all. And notice that is because of this semicolon. Essentially what we did here is we have an empty statement. So this is as if we have a completely empty thing. If temperature is greater than 98, don't do anything. If statement has ended, and no matter what we put, we're going to get, oh no, you have a fever. But that's not what we want, right? We did not design our program to work like this. How could we correct this if statement so that this program runs properly? If you're thinking about removing that semicolon, you would be correct. Here's a corrected version. So in this case, notice that there is no semicolon after my if statement. I simply have if temperature is greater than 98.6, we output, oh no, we have a fever, and then our program ends, right? We could put return 0 here, and we would be all finished. So notice the if statement does not end until it sees that first semicolon. Here, if I run this corrected version, if I ask what is my body temperature is 95, notice nothing happens. Only if temperature is greater than 98.6, then my if statement will trigger, right? So here, I do get the correct output. It's very important that you be mindful of semicolons when working with if statements. So remember, you do not put a semicolon right after the if. Instead, if your if statement has just one item that it's protecting, you put the semicolon right after that statement. What happens if we have two things? Notice what happens here. Now we're getting another warning. We're being warned that maybe our indentation is off. And that's because in this case, only the first item will be protected by that if. Once we see the semicolon, the if statement has ended. Let's see an example of this. Notice, even if we don't have a fever, we're told to go home and sleep. So if we want to put multiple things in our if statement, we need to use curly braces to associate everything with that if statement. And notice that I also indent within those braces. So now if I say my body temperature is 100, go home and sleep, both statements trigger because they are both protected by that if. Otherwise, if my body temperature is 95, nothing happens. So there you have it. Make sure you get really comfortable with these if statements, because we're going to be using them throughout this class. Okay, so if we return to our original question then, if we have this misplaced semicolon, the thing that actually happens is C. Because of the misplaced semicolon, our program had outputted, "Oh no, you have a fever," for any temperature. So remember, semicolons are like periods, indicating that a statement has ended. So if you put a semicolon immediately after the if statement, it creates what's called an empty if statement. And the statement itself does nothing. Remember, once we see that semicolon, our if statement has ended, and therefore the next code will trigger no matter what. So once again, here's an example of the corrected version of the program. Remember, there is no semicolon right after the parentheses. And then this way, the statement here, it will only trigger if our temperature is greater than 98.6. The semicolon marks the end of that statement. Let's take a look at another example. How about if-else statements? If-else statements are used to create branches. For example, we could ask ourselves if the answer if we answered correctly, right? We could say if our answer was correct, then what do? Then we say cout, good job. Else, if we did not answer correctly, then we could output that's incorrect. So notice we create a path. If our answer was correct, then we get good job. If our answer was not correct, we get a different response. And then the program continues as normal. So if and else can create branching paths in our code. So basically what happens here is if the Boolean expression is true, then the true statement runs. Notice the true statement will run only if the Boolean is true. Otherwise, if the Boolean statement is false, then the false statement will run, but again, only if the Boolean is false. So if you ever needed to write a program where you prevent code from running in certain cases, you can use an if-else statement to choose what code you want to run based on the Boolean condition. So a couple key takeaways. If our expression is true, we run the true statement. If our Boolean expression is false, we run the false statement in our if-else. Remember, we do not put a semicolon right after the if. But we do put semicolons after the true and false statements. Also, you do not have to include an else statement. Remember, we just covered the if statement where we simply have one check. But the else statement is needed if you want to choose between two possible outputs. Let's look at an example of if-else. Suppose we wanted to calculate an employee's pay, and the amount of money the employee is paid is based on how many hours they worked. So if an employee worked 40 hours or less, they get the normal pay. If the employee worked more than 40 hours, then the overtime hours, so any hours above the 40, those hours would get 150% of the hourly rate. How would we write this program? Well, let's go ahead and take a look at what this program might look like. Here is an example. Notice we first need to declare our variables. So we want to declare our variables for hours worked, hourly rate, and weekly pay. Next, we use cout to ask the user for the pay rate and hours. Then we use cin to get the value from the user. Here's the new bit of information. We can use an if-else statement to check whether we worked more than 40 hours. So notice, if we worked more than 40 hours, if hours worked is greater than 40, then notice our pay calculation is different. We get 40 times the hourly rate plus all hours above 40. Those get 150% pay. Otherwise, if we worked less than 40 hours or 40 hours exactly, then we just get hours times pay rate. Finally, we output the result back to the screen. This is actually a very simple program to write. I would encourage you to try going into your IDE and coding this up yourself. Verify that you can get this thing to run. Let's go ahead and demonstrate a few more things about this example. Okay, so here we have our payroll example. And you see we have our hourly rate, weekly pay, same approach as before. So if I go ahead and run this program, notice I can go ahead and see how much I'm paid. So enter the hourly pay rate. Maybe I'm paid $25.50 per hour. Number of hours worked. Maybe I only worked 10 hours. If I only worked 10 hours, I would expect my pay to be $25.50 times 10, $255 exactly. So we see that here we were paid hourly pay rate times 10 hours. But say that we make $10 an hour, and say we worked 50 hours. We would expect that the first 40 hours would be paid at the normal rate. So I'd get $400 for my first 40 hours, but then the 10 hours of overtime should be paid at $15 an hour. And if we do this calculation, we see that's what happens. We have $10 an hour times 40 is 400. Then we have our $15 an hour times 10 hours is 150. So our total pay, including overtime, is $550. What if we have a really big number? Suppose I make a lot of money, and say I worked a lot of hours. Well, that's not very helpful, is it? How could we make our program output dollars and cents and not scientific notation? If you're thinking about I/O manip and set precision, that would be a good approach. So notice what we can do is we can modify the program to also have include I/O manip. If we do that, then we can use the same formatting commands that we covered to manipulate the output such that we show 2 decimal places with set precision 2, show point to force the decimal to be shown, and fixed so that we show decimal notation not scientific. So let's try repeating the same exact program here. So my $10 million an hour times 50 hours. Oops, let's make sure we run the correct version. We run payroll improved. So here, I make $10 million an hour for 50 hours. Notice here, you will see my pay is still shown in dollars and cents, even if I have a large number. And I get 2 decimal places because of set precision 2. So once again, just to recap, if we want our program to show dollars and cents, then it's a good idea to make sure that we also include that I/O manip and use our set precision and other manipulators here to show decimal, not scientific notation, and 2 places. Another thing to notice how we formatted our output such that we include a period at the end of weekly pay. So we inserted weekly pay between the 2 strings of quotes. So by using these output manipulation and a little bit of nice formatting with cout, we can make our output look quite a bit nicer. Alright, so now let's cover some things to watch out for when using if-else statements. So here's one thing to be careful of, especially for those of you who are computer science majors. Remember, Bool variables already store a true or a false. So if we have this Bool variable is done, we do some stuff in our program. Suppose we have this if statement. If is done double equals true. This is what I call noob style, or a beginner programmer style. Remember, is done already is either a true or a false. So it's not necessary to say if is done double equals true. More experienced programmers will write if statements containing bools like this. So notice there's no double equal true or double equal false. Since is done already is a Bool variable holding a true or a false, we can simply write if is done. So is done is a Bool, so it's going to be either a true or false. If is done holds true, then I'm done triggers. If is done is a false value, then we just get no, I'm not done yet. This is a very minor style detail, so if I was grading your program, I wouldn't take off points for this, but it's something to notice because you will see that experienced programmers will simply write if is done. Because specifically for Bool variables already have a true or a false. So a more efficient notation is to simply use is done as your Boolean. Here's another thing to be careful of with if-else statements. If we need our if-else statement to contain more than one thing, so if more than one statement needs to be contained in the if or else, make sure you enclose the statements in braces. So we hinted at this a little bit earlier with the temperature example, where you need to use braces to show all the statements that trigger if our Boolean is true. If there are multiple things that must happen when we're false, then put the else statements in curly braces so that all the false statements are grouped together. Notice we also indent inside our curly braces. By good coding practices, you always want to indent inside your curly braces. It improves the readability of your program, and it's a good practice. You'll see later on that I will actually require you to follow these good practices while you are writing your programs. Okay, a couple other things to be careful of. We generally want to indent all the if-else statements that are at the same level. Indenting becomes very important when we have many if and else statements. And you'll see that this does happen quite a bit. Another thing to be aware of is that the compiler always pairs else with the nearest if that does not have an else associated with it. So you want to make sure that you use braces to tell the compiler how to group things. Let's take a look at an example of this. Suppose I have this program. I have some cost, and what happens if I set cost to 1.5? Take a moment and think about it. What statements will output if cost is 1.5? Let's go ahead and run this program in CLion to see what happens. Okay, so here we have our cost program. Let's see what happens if we set cost to 1.5 in this program. So we're asked what is the cost in dollars? Let's say 1.5, $1.50. Wait a minute. Is that the right output? Over $10? I'll wait for a sale? But we said the cost was $1.50. And shouldn't these statements run only if our cost was less than 10? Notice there are two statements here. And notice I'm getting a warning here. Add explicit braces to avoid dangling else. Notice what's happening here. This else statement is being paired with if cost is less than 1. Because if cost is less than 1 is the nearest if that else will be paired with. So how do we fix this? The compiler says we should add explicit braces. So the better thing to do in this case would be to make sure that we associate this else statement with cost is less than 10, not with cost is less than 1. So what we should do is let's add some braces so that we're very clear Notice here, if cost is less than 10, then we want our first if to trigger. To make it clear, we can also ensure that our program is indented such that it's clear if our cost is not less than 10, the stuff in our braces does not run, we move to else. Over $10, I'll wait for a sale. Notice if we run it with these changes, if we cost $1.50, nothing happens. We have to say if cost is less than $1.50, I can't afford not to buy that. Right? So here, cost is less than 10 and cost is less than 1, so we get I can't afford not to buy that. Else statement does not trigger. So notice how important it is to use braces to ensure that your if and else statements are grouped together properly. These braces ensured that our second if statement would only trigger inside our first one. These braces also allowed us to separate out this else statement and associate it with the if cost is less than 10. Okay, so just to summarize, we saw that the Cody sense question earlier was an example of the dangling else problem. The compiler wants to pair else statements with the nearest previous if, which does not have an else already. So this else statement was paired with cost cost less than 1, and that caused an incorrect output. We saw in order to fix this error, we had to use braces. So notice we used braces to associate if cost is less than 1 with our earlier if statement, and the braces also caused us to associate else with the correct if. So notice these braces would associate our else statement with the nearest unpaired if. So now that solved our problem. All right, now we have just a couple more examples to go. Suppose we wanted to write a program that gave students feedback on their homework scores. So if the student scored below 60, they would be encouraged to ask for help. Then depending on how well they did, they could either be given encouraging feedback or a great job. Let's look at an example of one way this program might be written. How about this? Suppose we have our homework score. We declare that as a double variable. And then we take the input from the user. Then we have a bunch of if statements that would supposedly output the feedback based on the score. My question to you is, would this program work? And in particular, if we scored above a 90, would we get the correct feedback every time? Take a moment and think about it. Okay, so what happens? Suppose we got a 95. Suppose the user gave us 95 as our score. So here we have a 95. Is 95 greater than 90? Yes, it is. So this statement will be outputted. How about this? Is 95 greater than 80? Uh-oh, it still is, right? So actually, even the 80 statement will output. And 95 is also greater than 70. So our third if statement will also be true. And even the last if statement will also be true if homework score is 95. The only thing that won't output is the last comment. So this isn't quite right? We don't want our user to get all the feedback if they get 100%. We only want the feedback to be given for the correct score. Here, the if statements are still true, and this is causing incorrect outputs. We need to redesign our if statements the if statements so only one correct message is shown. So there's a few ways you could do this. One way that I would recommend is to use elseif. So elseif is one way to offer multiple choices within an if and else. So if we use else if, notice we can say, all right, if homework score is greater than 90, we get a great job and we're done. If we're not greater than 90, then we continue. Then we just keep checking. We keep checking the other else ifs. So, okay, fine. Maybe suppose we got a 75. So homework score is greater than 90. No, that's not true, because in this case, 75 is not greater than 90. So first statement wouldn't trigger. Is homework score greater than 80? Well, 75 is not greater than 80. So second one doesn't trigger. But if homework score is greater than 70, 75 is greater than 70. So we get the desired output. And then notice after that, we're done. Then notice 75. These statements will only trigger if the earlier statements weren't already true. So we only make it all the way to the bottom of these else ifs if our homework score is greater than 60, but not greater than 70. One way to think of this is multiple branches. If we're greater than 90, we go one path. Greater than 80, we have another choice. Greater than 70, we have another choice, and so on. So we're creating multiple different pathways that we can branch off of depending on the score. So this is why we call it a multi-way if-else statement, because we can use multiple else-ifs to create more than two branches. One last tool we'll cover today is a switch statement. Let me just be clear that switch statements are not used that often. Usually, we prefer to use if, elseif, because it's more flexible. Switch statements only work with int and char expressions. And typically, we use switch statements for making menus. So one example of this is maybe you're doing a multiple choice question or a choose your own adventure book. So if you have a very set list of options, then a switch statement could be an acceptable choice. So once again, it's easier usually to use if-elseif, but switch statements are a special case that are sometimes used for menus. Here's how a switch statement works. We have the word switch followed by an expression. This expression must evaluate to either an int or a char. So the expression is compared with each case. So we have case, each case is numbered. So with each cases, exp1, exp2, etc. So we compare the expression with each case, and so each case must be a unique possible option. If we find a match, if the expression matches a case, we trigger that case and any cases after until we reach the end. And then if no match is found, then we use the default case. So default is optional, but it's recommended to make sure that you handle any possible expression that is given. There's one more thing you should know about switch statements. Often we include what's called a break statement within the switch. Break statements are used to exit a switch statement after a case triggers. So if we do not include this break statement, the program will keep executing all remaining switch statements. We call that falling through. So we'll execute all the remaining switch statements, which generally we don't typically want that to happen. Instead, if we intentionally omit the break statement, we could actually allow multiple cases to use the same code. So here, both capital A and lowercase a will get the same output. And notice, remember, char values must be enclosed in single quotes. Let's look at an example. Here's an example of a switch statement, which is used to give comments on a grade. So we ask the user for their grade. Notice it's a char type value. So grade is some character. And then notice we compare, using the switch statement, we compare the grade grade's char value to the possible options. So if we got an A on our midterm, then we get excellent. You don't need to take the final. And then the break causes us to exit the switch statement. Notice if we got a D or an F, we would get the same output, because the break doesn't happen until after the F case. And by default, if we give some other letter besides A, B, C, D, F, then we get that is not a possible grade. Notice how we need to include break statements between each option. This prevents more than one output from triggering, or more than one case from triggering. Let's open this program in CLion real quick. And let's see what happens if we got rid of those break statements. Okay, so here's our switch statement example. So again, we have a similar program here. And notice that we have those break statements in place. So depending on what grade we get, we will see an output, and then it will break. Let's go ahead and run this thing and see what happens. Okay, so if I enter my midterm grade and press return, notice if I get an A, I get some message. I get excellent, this output happens, and then notice because of the break, I exit the switch statement, and then end of program triggers. Let's just pretend that these break statements weren't here. I'm just going to comment them out so that they don't trigger. Now my break statements are gone, right? If I run the same exact thing again, look what happens. If I do not include these break statements, case A triggers, but case B also triggers. And then case C, and even case D and F. So I need to have these break statements between each case in order to prevent statements from triggering where I don't want. So again, we want to leave those break statements in there because when we get an A grade, we only want to see the output from case A. Notice, however, that we did choose to exclude a break statement between case D and F. We did that on purpose because regardless of whether we get a D or an F grade, we wanted to output the same message. And finally, if we give some other letter that's not a valid grade, the default will trigger because letter O was not one of our possible cases. All right, so there you have it. We have now covered a variety of ways to make decisions in our programs. And so please make sure you try going back through these examples yourself and make sure you understand how they work. You should now be able to explain how we can use Boolean statements to check whether conditions are true or false. Once we've written these Boolean statements, we can create if, else, elseif, and switch statements to create branching programs. Also, you should now be able to watch out for common errors that occur when writing programs with these statements. I'd highly recommend that you try going back through these examples we covered. Make sure you understand them. Play around with them a little bit, or try building them from scratch. That way you'll get even more practice, and these topics will become much easier. Feel free to reach out if you have any questions, and we'll see you in the next video.